Again, welcome to statistics. This part is the inferential statistics. So we're going to study about the confidence intervals for the mean using the large samples. When we say large samples, we mean when the size of the sample is either greater than or equal to 30. So again, this is inferential statistics, confidence intervals. So our main topic is confidence intervals for the mean. Now, our main objective is to learn how to find the point estimate and also the margin of error. We're also going to learn how to construct and also interpret the confidence interval for the population mean, and also how to determine the minimum sample size required when estimating population mean. So let's start with the point estimate for population mean. Here we say a point estimate is a single value estimate for a population parameter. Now, what we mean by this, as we said earlier, in inferential statistics, we are not going to use our population for the studies or if we are doing the research. Because of time consuming, population is too large, and also the money that will be involved in to spend and collecting all population. So we are going to take a sample. Now, when we take a sample, we said earlier there are many ways of taking sample. There are at least 4 different methods. We went through that. But the whole concept here is that we don't want our sample to be biased. We want to do our best to remove any bias from the sample. So the sample have to be well representing the population. Now, with the concept of point estimate, I have a population. I want to do some studies. I will take a sample from the population to use so that I'll use less data. It will take me less time, less cost of the studies. Now, the result I will get on the sample, I'm going to apply it to the population to generalize it. Now, point estimate means I'm going to use a single value estimate. Then I will apply that single value estimate of the sample to the population. So here we say single value estimate for a population parameter. Now the concept here is we are dealing with mean. This is one of the basic inferential statistics concepts. So if I want to find the average weight of a population that is, let's say in New York City, 2 million or 10 million population, I want to find the average weight of this population. Well, I don't want to take my time to take all the weight of 10 million people. I will take a sample of maybe only 100 or 1,000. Then when I find the mean of that sample, I will say the population, that's their mean also. So here I'm finding a single value. So that is the point estimate, single value. I find the mean of the sample, one single value. And now it's okay, the population over 10 million, they have the same mean. So here we say most unbiased point estimate of population mean is the sample mean. And again, we have the symbol for population parameter. The mean is mu. The sample statistic is S bar. Now let's try this example here. So here we say we have a market researchers that use the number of sentences per advertisement as a measure of readability for magazine advertisements. Now the following represents a random sample. Again, the keyword is sample. The following represents a random sample of the number of sentences found in 50 advertisements. Find a point estimate of the population mean. A point estimate should be single value of the sample, and we are going to apply the result to the population. So this is the data set given to us. There are 50 of them. So we are going to add all these 50 values, divide by 50. And that's what we have here. When we add all the values, we get 620. We divide 620 by 50, we get 12.4. So our point estimate for the mean length of all magazine advertisements. So the keyword we are saying is all, which means the population. So your point estimate for the mean length of all magazine advertisement is 12.4 sentences. So this is, again, the concept of point estimate. Next, we move to the interval estimate. Interval means we have to have some range of values. And when we are dealing with interval, the level of confidence will come in. So for example, we find the point estimate in the previous example to be 12.4. Now, based on some margin of error, plus or minus, we were able to come up with an interval. The interval is between 10.5 to 14.5. Now, what we have to know here is that we can say something like we are 90% confidence that our mean population will be between the value of 10.5 to 14.5. So that's what we call the interval estimate. So interval estimate have to be some range of values. So here we say an interval or range of values used to estimate the population mean. Point estimate is a single value that is used to estimate the population parameter. So how confident do we want to be that the interval estimate contains the population mean? This is where the concept of level of confidence, critical values come in. So level of confidence C is the probability that the interval estimate contains the population parameter. So I can say, okay, I'm 90% confidence that the mean of the population will be between 10.5 to 14.5. By the point estimate give us 12.5. By the interval will be 10.5 to 14.5. So this example, we can use the normal distribution curve. So the area under curve, which is the shaded area, will be our C. Then we have the critical values from negative ZC to positive ZC. At the center, the Z is 0. So this is a standard normal curve. So we said the critical values will be from negative ZC to positive ZC. So if we know that, then the remaining area which is not shaded will be 1 minus ZC. And that's what we have here, 1 minus ZC. So for left side alone, it will be half 1 minus C. Or to the right, to the same thing, half 1 minus times 1 minus C. So that's what we have here, half times 1 minus C, half times 1 minus C. So again, this is a standard normal curve. So here, to get the Z value, we can use the standard normal table. So level of confidence, let's see an example here. They say if the level of confidence is 90%, this means that we are 90% confident that the interval contains the population mean. So I'm 90% confident that the mean will be between 10.5 to 14.5. That's the interval estimate. So that's our diagram again. 90% C, so 0.90. The remaining will be 0.10. So that means I have 0.05 to the left, 0.05 to the right. Now, if I want to find a Z value, I'm using 0.05 concept. You go to the standard normal table, we get negative 1.645 or positive 1.645. So next we move to the sampling error. The concept of a sampling error, here again, we are using the sample and apply it to a population. So sampling error means the standard deviation of the sample. And here we say the difference between the point estimate and the actual population parameter value. That's another way of saying it. Sampling error. The difference between the point estimate and also the actual population parameter value. So for mu, the sampling error is the difference of what? The S bar and the mu. Mu again is generally unknown. S bar may vary from sample to sample. If I have a population of 1,000, if I take a sample of 10, next time I take different sample of 10, most likely their sample mean values again will be different. So that will take us to margin of error too. So the margin of error is the greatest possible distance between the point estimate and the value of the parameters it is estimating for a given level of confidence. So based on the definition, we can say that the margin of error is the value that we will add and subtract to get the interval. So the point estimate is one single value, but confidence interval or interval estimate, it will be point estimate value plus or minus the margin of error. So this is again the formula for finding the margin of error. Here we say the ZC times the standard deviation of the sample. So we said earlier the standard deviation of a sample will be the population standard deviation divided by square root of the sample size. Here we are doing large numbers, so we say when n is greater than or equal to 30, the sample deviation S can be used for, again, population standard deviation. So again, this is the formula. We will get a ZC value by using the standard normal table corresponding Z value. Then we know the standard deviation of the sample will be standard deviation of the population divided by square root of n. So sometimes the margin of error also is called the maximum error of estimate or the error tolerance. So let's see an example here. Here they say find the margin of error. Use the magazine advertisement data. This was previous example we have with the 50 magazine advertisement data set. And this time we have 95% confidence level to find the margin of error for the mean number of sentences in all magazine advertisement, assuming the sample standard deviation is given to us. So we know the data set. We were previously, when we do this example, we were able to find the point estimate, which is one single value mean, by adding all the 50 values divided by 50. But now we want to find some interval, and we are 95% confidence interval level. So first thing we have to be concerned is get the margin of error. The margin of error we add and subtract from the sample mean, and that will give us the interval. So this is the question. Remember, 95% confidence interval. So our shaded area will be 0.95, which is 95% confidence interval. Now, if I have 0.95, to the left and to the right will be 0.025 because both sides are 5%. So half of 5% will be 2.5%. 2.5% is the same as 0.025. So we got the diagram correctly. Our goal now is to find the critical values here. So we go to our Z table or the standard normal table, and we're going to find the value to be 1.96. The positive side again is 1.96 or so. So here we say that 95% of the area under the standard normal curve falls within 1.96 standard deviation of the mean. And we can approximate the distribution of the sample mean with a normal curve by the central limit theorem, because our n again is greater than or equal to 30. So now we know the critical value, so now we can find the margin of error. So the margin of error will be ZC, standard deviation, divided by square root of n. So we go back to our standard normal curve. Remember, we have 0.95, 95% confidence interval. So the significant level will be again 0.05 or 5%. So when you look at the standard normal table, that will give us 1.96. The standard deviation was given to us to be 5.0. And again, the sample size is 50. So if we solve this problem using calculator, we get 1.4. So we say we are 95% confident that the margin of error for the population mean is about 1.4 sentences. Again, the margin of error. The confidence interval was given to us to be 95%. So here we say we are 95% confident that the margin of error for the population mean is about 1.4 sentences. So next is the confidence interval for the population mean. So as we said earlier, confidence interval means minus the margin error from the sample mean, then to the right, add the margin of error to the sample mean. So this will give us, again, the range of values between lowest to the highest. So the probability that the confidence interval contains mean is C. So let's find a confidence interval for population mean. Here we say the mean is greater than or equal to 30. Or the standard deviation, no, with normally this is normally distributed population. So in words, first we have to find the sample statistics, the n, that is the size of the sample, and also the mean of the sample. In symbol, this is what gives us the point estimate. It will be S bar equal to the sum of all the S value divided by number of n. Then step 2, we have to specify the standard deviation if known. Otherwise, we say if n is greater than or equal to 30, then we should find the sample standard deviation S and use it as an estimate for the standard deviation. So S again is the sum of a value, each value in the set minus the mean or square. Since it's a sample, we divide by n minus 1. So this will be again our standard deviation. Then the third, again, second, again, we saw this is for our standard deviation for the sample. So we find the mean, which is the point estimate, then we find the standard deviation of the sample. The third step, we find the critical value ZC. Now, critical value will be depending on the level of confidence they gave us, or we can also find it. So find the critical value ZC that corresponds to the given level of confidence. Here we use the standard normal table. Then if we know that, then we can find the margin of error. Margin of error is what? The ZC. The ZC is what we find in number 3, the critical value ZC that corresponds to the given level of confidence. So the margin of error E equal to ZC, standard deviation divided by square root of n. Then now we're going to find the left and the right endpoint, then we form the confidence interval. So the main thing is finding the margin of error. We subtract it from the mean, we get to the left starting. We add it to the mean, we get to the right starting. So that's why we say S bar minus E, the margin of error. That's the left endpoint, and the right endpoint will be S bar plus the margin of error. So this will be our interval. The mean will fall between the sample mean minus E to the sample mean plus E. So let's try this example now. Construct a confidence interval. So we start from beginning, construct 95% confidence interval for the mean number of sentences in all magazine advertisement. So first we know this, that this is the same question number 1, sample 1 data set. We know the S bar means we had all the sample mean for the values, I think it's somewhere 50. Then we divide by 50, and that gives us the S bar. Then the same thing we do for the E. The E we know is ZC, standard deviation over square root of n. We get 1.4. So if I know the E, the left hand point will be the S bar minus E, and the right will be S bar plus E. So here, instead of 12.5, our interval is between 11.0 to 13.8. And we can see the diagram here again, 11.0 to 13.8. And this question, we are 95 confidence that you can say that the population mean number of sentences is between 11.0 to 13.8. Now let's try another example. Here they say construct a confidence interval, standard deviation known. So a college admissions director wishes to estimate the mean age of all students currently enrolled. Now in a random sample of 20 students, so we have random sample of 20 students, the mean age is found to be 22.9. Now we say from past studies, the standard deviation is known to be 1.5 years, and the population is normally distributed. We should also construct 90% confidence interval. So we have all the necessary values now. Remember, we are constructing 90% confidence interval. So our goal is to know what is E, then we add it to sample mean, then we also subtract it from sample mean. That will be the left end. So we have our normal distribution curve. The level of confidence they gave us was 90%, so it's 0.9. So this means I'm sure 0.05 to the left, 0.05 to the right. Total will be 100 again, percent or 1. So first find the critical values. So we have our Z values. Based on this, we were able to get negative 1.645. And again, positive 1.645. This would be these two values, again, negative 1.645 and positive 1.645. We get this value from our standard normal table. So based on this, we can say that the ZC is 1.645. Now, if I know the ZC, then I can find the margin of error, which will be, since the size of the population is greater than 30 or equal to 30, the margin of error will give us ZC times standard deviation of the population divided by square root of n. So that's the confidence interval in final. We say again 22.3. Then to the right, we had the S bar to E, we get 23.5. So it will be 22.3 to 23.5 for our confidence interval. And we can see the diagram here. Now the next is how to interpret the result that we get. We say the mu is a fixed number, so it is either in the confidence interval or not. So incorrectly, we can say there's 90% probability that the actual mean is in the interval. So this is wrong. 90% is wrong. Probability that the actual mean is between. But correct way will say that if large number of samples is collected and a confidence interval is created for each sample, then approximately 90% of this interval will contain mean. Now, that's the condition. If the sample is large, that is 30 or more. And also the confidence interval is created for each sample. It can be 95%, 80%. Here it was 90%. So if that is the case, then we should be able to find, let's go back one. So we know the correct, again, the interval. If we understand this, we say that the horizontal segment represents 90% confidence interval for different samples of sample size. So in the long run, we say 9 of every 10 such intervals will contain mean. Now, next we go to sample size, where very, very important. Sometimes we may have a result that we may say that, okay, based on the result given to us, we should know the sample size we are going to use. So here we say, given a C confidence level and a margin of error E, the minimum sample size N is needed to estimate the population mean is N equal to ZC, standard deviation over E. So we say, okay, if the standard deviation is unknown, you can estimate it using S, provided you have a preliminary sample with at least, so that's what we say, the sample size should be at least 30 or more. So this is an example for sample size. Here we say you want to estimate the mean number of sentences in the magazine advertisement. How many magazine advertisements must be included in a sample if you want to be 95% confident that the sample mean is within 1 sentences of the population mean, assuming the sample standard deviation is about 5.0. So here we can say that we have the percentage, 95 confidence interval, 0.025, 0.025. We get a ZC. That is the case. We should be able to find the N, which will be ZC times standard deviation by E. And here the answer again will be 96.04. So roughly we can approximate that the sample size will be 96 or 97. So we'll run it again to 97. So this will be our end of this lecture. So in summary, again, we learned how to find the point estimate and margin of error. We also constructed and interpreted confidence interval for population mean. And also we learned how to determine the sample size based on the values given to us like ZC, the E, etc. So most importantly, we should know the difference between the point estimate and confidence, the estimate interval. When estimate interval comes in, then we have to know the confidence interval also. So again, wish everybody the best, and again, thank you.